Assalamualaikum and a very good day. So this is second example problem solution step. This is example 10.3 from Thermodynamics engineering textbook, Chengel. So in this question, it is about the effect of boiler pressure and temperature on efficiency whenever we want to improve the efficiency of our steam power plant. So let's read the question first. Consider a steam power plant operating on ideal Rankine cycle. Steam enters the turbine at 3 megapascal with 350 degrees C and is condensed in the condenser at a pressure of 10 kilopascal. So they have three questions overall. Question A is determine the thermal efficiency of this power plant. B, thermal efficiency, determine thermal efficiency if steam is superheated to 600 degrees C, instead of 350 degrees C in the question A. And then C, the thermal efficiency if the boiler pressure is raised to 15 megapascal while the turbine inlet temperature is maintained at 600 degrees C. So to answer this question, we have to do one by one. We have to solve questions one by one. So we go to question A first. So to answer this question, we have to do one by one. But as usual, we make an assumption first. That the steam power plant operating at steady state kinetic energy and potential energy negligible. Alright, now we do the solutions. Let's do solution A first. So the steps are exactly according to the previous example in the previous video that I recorded. So please watch that video first. I show step by step, including how can we read the table A4, A5 and A6 from the textbook. So please watch that video, then come back to this video. Okay, so for this video, for this question, we do one by one according to question A, B and C. So for question A, the steps exactly the same. We have to find out the enthalpy H and also all the values related. Okay, so for question A, point 1, the pressure is 10 kPa. Do they have the temperature? No. So what we can do, we read the table A4. So what we do, we read table A5. So at point 1, the pressure for the point 1 is 10 kilopascal. So definitely we want to have enthalpy. So be careful. I mentioned in the previous video they have saturated liquid, they have evaporated, they have the saturated vapor. Point 1 is definitely saturated liquid. Point 1 kan dia dalam bentuk water saja. So 191 lah. Then don't forget to write saturated fluid, saturated liquid. So the HF, which is the fluid, is equal to I think better we write HF1. Okay, enthalpy fluid at point 1, that's much better kan, 191.81 kilojoule per kilogram. And then we also better take the value for the specific volume as well. For the fluid 1, Okay, 0.1 equal to 0.00101 meter cube per kilogram. Okay, how about at 0.2? So 0.2 is equal to what the value that we have at 0.2. First, the value at 0.2 is, we cannot take careful. I remember some students, they mistakenly thought that 0.2 also 10 kilopascal. No, 0.2 the pressure is already 3 megapascal. Dia ambil yang atas ni, yang ni, not this one. For 0.2 take this one. Okay, 3 megapascal. How about the phase of phase of the working fluid? Is it a liquid or the vapor? We don't know, but we know that from the ideal Rankine cycle curve, that 0.1 and 0.2 they have the similar entropy, S1 equal to S2. So bila kita ada S1 equal to S2, then we can calculate what is happening between the 0.1 and 0.2. Dia ada kat sini, dia ada pump, the value pump, kan, pump in. So we can calculate it based on this situation. W
pump in equal to V1 ataupun specific volume at 0.1. Kenapa? Sebab entropinya sama. Bila entropi sama, volume, specific volume also sama, also similar. So V1 P2 minus P1. So V2 P2 minus P1 is equal to, you just insert back the value 101. P2 is 3 megapascal, so 3000. We change it to, convert it to kilopascal, minus 10. So we get the value of 3.02 kilojoule per kilogram. Okay?
I mentioned why we have to use this method to get the value for the Q. For the H at 0.2. Please watch the previous video. So H2 is become H1 heat enthalpy at 0.1 plus the work of the pump. Kan pump berlaku in between 1 dengan 2, so dia just tambah sajalah. H1 kita dah tahu dah, 191.81 plus 3.02, so we get the value of 194.83 kilojoule per kilogram. Sorry for my very not clear handwriting. Okay, now we proceed at 0.3. We already finished 0.1, 0.1 dah, and 0.2. Now we're doing 0.3. So at 0.3, given in the question, P at 0.3 is 3 megapascal, and we know at this point it's no longer liquid, right? It's vapor. One. Second is it's already in the situation of superheat. Superheat. So kenapa kita kena mention superheat state ni? Sebab nanti nak baca table. Bila superheat table state, dia bagi temperature adalah berapa? Temperature dia bagi 350 degrees C. Jadi kita baca balik dalam table. Yang ni kita refer table yang 0.1 tadi, kita refer table A6, A5 kan. Kalau table A5 or A4, you double check. Kalau untuk at 0.3 3 megapascal with superheated state ni, temperature 350 degrees C, we refer to table A6. So A6 you akan tengok, again I explain very detailed in the lecture video number 1, so please watch it. We get the value for the enthalpy 3, which is 3116.1 kilojoule per kilogram, and then we get the entropy of S3 equal to 6.7450 kilojoule per kilogram Kelvin. Okay, how about at 0.4? 0.4 dekat sini kan. So 0.4 pressure nya nak pakai yang 3 megapascal ataupun 10 kilopascal. So we have to use 10 kilopascal. Okay, use 10 kilopascal, tapi state nya adalah saturated mixture, meaning dia adalah mixture of steam and water. So we have to do the fraction calculation sikit je, but in the same time we know that S4 equal to S3. S3 kita dah dapat tadi kan, ni S3. S4 kita nak calculate. So S4 pula, S4 kita nak calculate pula. S4 equal to S3, then we already know that S3, definitely S4 is equal to S3. So we use this equation, X4, meaning a fraction at point 4 equal to entropy at point 4 minus entropy fluid over entropy for evaporated ataupun the mixture of fluid and gas. So mana nak dapat SF dengan SFG? Okay, SF boleh diambil daripada table A5. SFG juga boleh ambil daripada table A5 juga. Dua-dua sama. S4 ni pula sama dengan S3. Saya tunjuk detail juga tadi ada dalam video yang pertama pasal benda ni. And then kita akan dapatlah nilainya, iaitu
6.7450 minus 0.6492 over 7.4996 equal to 0.8128.
So is it the solution for the state 4 ataupun point 4? Not yet, because we want to find enthalpy, kan? Dengan enthalpy baru boleh kita calculate thermal efficiency. So we calculate, hence to get the H4 similar macam masa kita buat calculate untuk H2. H4 equal to HF plus X4, fraction of X4, okay, times HFG. Enthalpy mix of fluid and gas. So kita pakai nilai ni. So fluid kita dah calculate, kita dapat HF kita adalah 191.
Sama je, HF ni sama lah dengan point 1 tadi, point number 1, 81 kilojoule per kilogram plus X4 0.8128 times HFG ya. HFG nak baca dekat mana? HFG boleh baca daripada table A5 juga. 92.1. So akan dapatlah HX4. So 2136.1 kilojoule per kilogram.
And then Q in is equal to H3 minus H2. You dapat calculate direct lah. Mana H3 dengan H2? So H3 enthalpy dekat point 3 adalah yang ini. Yang ini. Dengan H2 ni adalah enthalpy pada point 2 dengan ini ya. So kita dapatlah jawapan akhirnya adalah apa tu? 2921.3 kilojoule per kilogram. And then we also can calculate for Q out. Ini nak calculate untuk thermal efficiency lah ni. Okay. So Q out ni kita nak ambil yang mana? H4 minus H1. Kenapa kita ambil Q in, Q out dekat situ tadi saya dah explain dalam yang sebelum ni. Saya explain yang berlaku pada point Q in dan Q out dekat mana. Q in ni berlaku dekat sini kan. Ni Q in. Maksudnya heat we bring inside the substance. Macam tu. Siapa punya kerja ni? Boiler punya kerja. And boiler, boiler heating up the water to become steam. And then yang Q out ni kat mana? Kat sini Q out. Q out siapa punya kerja? Condenser. Dia keluarkan temperature daripada working fluid tu, daripada steam, so that dia jadi water yang clear, water with low temperature. So Q in minus apa nama ni? Q in dan Q out kita nak calculate lah. So kalau Q in antara 3 dengan 2 kan. So Q out antara 4 dengan 1, 4 and 1. So we get the value for H4 minus H1 1944.3 kilojoule per kilogram. And then definitely the thermal efficiency, macam ni lah bentuknya. Thermal efficiency untuk case 1, case 1 is 1 minus Q out over Q in. Then tuan-tuan masuk sajalah value nya, kan? 1944.3 over 2921.3, then akan dapat nilai 0.334 ataupun make it in percentage 23.4%. Okay, that's question A.